Okay. I'm Akilu Hazelton from the 403 to the HAZ. Mr. Nelson in the house here to quickly and painlessly teach you how to solve for x when dealing with radicals. And when attacking these kind of problems, there are a series of steps to follow every time. And if you follow them, you should be fine. Step 1, identify. I have a better block than this. Identify the most complex radical. Sometimes there is more than one radical, so we have to identify the most complex radical. Ish. Doesn't have to be, it's not a science. Okay, step 2, isolate that radical. You can't sit with us. Isolate that radical. What do we mean by isolating? Move it alone to one side of the equal sign. That's what isolating means, okay? 3, square both sides of the equal sign. Hope you guys can see this because this is fading. And this means square the entire of both sides, and we'll talk about that in a bit. Equal sign, and then 4, if after of the equal sign and simplify. So expand and simplify. And then 4, you ask yourself, is there a radical remaining? Question mark. And if the answer is yes, that means you go back to step 1 and start the iteration again. And if the answer is no, yippee, good for you. You can now solve for x. Okay, and solving for x may be as easy as solving for x, just isolating for x and solving for it. But sometimes we are going to wind up with quadratics, where we are going to have to use factoring, or if we're lazy, the quadratic formula. So here are the steps, fairly straight, not bad. So let's see how that looks like in practice. I'm going to just do a few problems here. So let's say we had a problem that gave us the square root of 3x plus 7 is equal to 21. Well, we go to the steps. Identify the most complex radical. I only have one. So I'm going to isolate that radical. It's already isolated. Now I'm going to square both sides. Oops, I'm going to square both sides now. And what happens when I square this monomial? This is one term, all under the radical. So I'm going to consider it a monomial that I am squaring. And basically what's going to happen is, because everything is under here and there's no other terms, this square is going to cancel our square root, and we're going to be left with 3x plus 7 is equal to 400 and, is it 44? Let's see here. 441. 21 squared is 441. Now, is there a radical remaining after I do that? No. So I can just go ahead and solve for x. To solve for x, I'm going to subtract 7 from each side. Cancel that. And then I'm going to be left with 3x is equal to 434. And I'm going to divide both sides by 3. And And that leaves me with x is equal to, and I think this is not going to simplify, so this cancels with this. X is equal to 434 over 3. Just make sure here. Yeah. So we'll just leave it in that form because it cannot simplify it any further. Okay. That's kind of our baseline, fairly easy example. You can see that plays out quite easily. So let's do another example here. Let's try this guy right here. So let's do 4 root x minus 4 is equal to x. Okay, again, I identify the most complex radical. I only have one, and that's it. So I'm going to isolate that radical. In this case, to isolate that radical, I'm going to have to add 4 to each side, which will leave me with x plus 4. And I can see I have a 4. This is a mixed radical. I have a 4 in front of this radical. So I could divide out the 4 just so I have the radical alone. But in this case, if I divide out the 4, I'm going to have something like this that I'm going to eventually have to square. And that looks kind of complicated. So I'm actually going to leave the 4 with the x. And I'm going to just square both sides in their entirety. So I'm going to square all of this. And then I'm going to square all of this. Now, if I remember the part about multiplying mixed radicals, I can multiply what's inside the radicals together, and I multiply the number sitting in front of the radical with the number sitting in front of the radical. So when I do this, it's talking fast, sorry. When I do this multiplication, it's going to be 4 root x times 4 root x on the left side. That's the square. And then on this side, when I say square both sides, I don't come in and say, okay, I'm going to square the 4 and I'm going to square the x. No. I have to square the entire side. So that's why I'm going x plus 4, square the whole thing. And this is a binomial, so I have to multiply this as I would binomial multiplication. So on the left side, the 4 is going to multiply with the 4, and the root x is going to multiply with the root x. So then I'm going to get, on this side, 16 times x, or x squared. And the square root of x squared is just x. And I can tell that when I multiply a square by itself, I'm just going to get whatever number was inside the radical. So I have 16x on this side is equal to x times x is x squared, x times 4 is 4x, 4 times x is 4x, and 4 times 4 is 16. And as it says, I simplify as well. So I'm going to simplify. I'm going to collect terms. I've got 4x and 4x here. So I have 16x on the left is equal to x squared plus 8x plus 16. And then, is there a radical remaining? No. So I'm going to solve for x. And in this case, I can tell I have a quadratic now. So I am going to solve the quadratic by moving everything to one side. And to do that, I'm going to subtract 16x from this side to leave 0. And I will have x squared, I have to minus 16x over here. 8x minus 16x is minus 8x plus 16. And now I'm going to factor this using product sum. So, because there's no term in front of the x squared, I am looking for two numbers that multiply to 16 and add to negative 8. And those two numbers are negative 4 and negative 4. So that my answer here is x minus 4 times x minus 4 is equal to 0, or x is equal to 4. Do you answer is x is equal to 4 because when x is equal to 4, 4 minus 4 is 0. 0 times any number is 0. That will make the left equal to the right. So a value of 4 for x is what makes this equation true. So x is equal to 4 is our answer on this one. Let's try another one. So I've got square root of x plus 2 is equal to x. I'm going to go through the steps. I'm going to identify the most complex radical. It's just this right here. So I'm going to isolate that radical by subtracting 2 from each side. Now I have root x is equal to x minus 2. I've isolated the radical. Now I'm going to square both sides. And I can do that. So square that and then square all of this, a binomial. Now I know that the square root of x times the square root of x is just x. And this becomes x minus 2 times x minus 2. And when I do that multiplication, I get x is equal to x squared minus 2x minus 2x plus 4. And I'm going to simplify or collect terms. X squared minus 2 is minus 4x plus 4. Again, I have a quadratic here. So I am going to move everything to one side so that I can solve it by factoring because I do not have a radical remaining. So to do that, I am going to subtract x from either side. And I get 0 is equal to x squared minus 5x, because I've collected an extra negative x, plus 4. And now I do my product sum to solve this. Two numbers that multiply to positive 4 and add to negative 5 are going to be negative 4 times negative 1. So that my factored trinomial is x minus 4, x minus 1 is equal to 0, meaning that the two values of x that will make the left 0, so that this statement is true, are x is equal to 4 and x is equal to 1. And that is my solution. Just following the steps every time. So let's do one where we have more than one radical at the beginning. See how that plays out now. This is where the process gets a little longer. It doesn't get any more difficult, it just gets a little more tedious. So let's try the square root of 5x minus 1 plus 3 root x is equal to 1. So I go through my steps. First step, identify the most complex radical. I would say that this is a little more complex than this one. This one's a mix. This one just has more, it's a binomial within that radical. So I'm going to go with that one. I'm going to isolate that radical. And to do that, I can actually just subtract an entire 3 root x from both sides. And when I do that, I get this. So that cancels out. And I'm left with 5x minus 1. Square root of 5x minus 1 is equal to 1 minus 3 root x. Okay, my more complex radical is isolated. Now I'm going to square both sides. I'm going to square this side and square this side. And when I square this left side, everything is sitting under the radical, so this square is just going to cancel out the radical, so that I'm left with 5x minus 1. This side is going to be a little more complicated, and we are going to have to remember how to multiply binomials with radicals. So to do this multiplication, 1 times 1 is 1. 1 times the negative 3 square root of x is going to just be negative 3 square root of x. I just have one of those. Negative 3 square root of x times 1 is again negative 3 square root of x. And then negative 3 square root of x times negative 3 square root of x is, well, the 3's are going to multiply together to give me 9, a positive 9, negative and negative. 3 and 3 come together. And then the square root of x times the square root of x is just x. So that becomes this. And I am going to simplify by recognizing that I have 2 negative 3 root of x's. So 5x minus 1 on this side is going to be equal to 1 minus 6 root x plus 9x. Now, is there a radical remaining? Yes, there is. Now I have a negative 6 root x. So I have to go back to step 1, and I've identified that this is my most complex radical, and I'm going to isolate it. And I'm going to isolate it by moving it to this side and then moving all of this back over here. So I will do that first by subtracting, well, I'm going to get rid of the 1 by adding 1. I'm going to add 1 here, that goes away, and then I'm going to subtract 5x. Subtract 5x. Now, and then I'm going to add 6 root x on this side, and I'm going to add 6 root x on this side. So that cancels, and I am left with 6 root x is equal to 2, 9 minus 5 plus 4x. So I've isolated the radical, now I'm going to square both sides again. So I'm going to square this side. I'm going to square this side. This side, I know, will be 6 times 6, and then root x times root x. So 6 times 6 is 36. Root x times root x is x. 36x is equal to this binomial, multiplication. So I'm going to bring this back up here. So I have 36x is equal to 2 times 2 is 4. 2 times 4x is 8x. 4 times 2 is 8x. And then 4x times 4x is 16x squared. Now I have a quadratic again. So I'm going to move this 36 over there, simplify, and then try and solve this quadratic, because I don't have a radical remaining. So I'm going to move 36 over, and I get 0 is equal to 4, 8 plus 8 is 16, plus 16x, minus the 36x we moved over here, from over here, plus 16x squared. And then if I rearrange and simplify that part, I'm going to get 16x squared minus 16 minus 36 is minus 20 plus 4. I'm worried I've made a mistake here, but I'm just going to trust the math. So I have a quadratic here that I can solve using, I have a number in front of my x squared term, so I'm going to have to use decomposition. But first, let's see if I can factor anything out. I think I can. I can probably factor out a 4. 4 times 4x squared plus minus 5x plus 1. And I can divide both sides by 4, and I'm left with the 0 is equal to 4x squared minus 5x plus 1. Okay, two numbers that multiply to 4. Well, let's do the proper decomposition here. So Well, I'm going to need two numbers that multiply to 4 and add to -5. And those are going to be -4 and -1. So I can replace -5 as the sum of these two. If you don't understand what I'm doing, check out my video about decomposition. It'll explain this form of factoring. So 0 is equal to 4x squared minus 4x minus 1x plus 1. I've replaced -5 as the sum of its two parts here. And now I'm going to split this up and I'm going to factor it. And I'm going to pull out a 4x on the left side, which gives me x minus 1. I'm going to have x minus 1 on this side. And times, that should be a negative, yeah, times minus 1 on this side. Which means that my result will be x minus 1 for x minus 1 is equal to 0. Therefore, my answer for x is equal to 1 and 1/4. Looks like a lot of work. It's a lot of number counting. You have to have attention to detail, but it's doable. And that is how we do solving radical equations for x. Thank you.